Welcome to section 1.1. Our essential question, how can we use the index to help simplify a radical expression? Okay, so what is that even asking us? Radical is referring to a square root symbol, maybe a cube root or fifth root or anything like that. That's what they mean by radical, so that's that symbol right there. Index is going to be whatever you see inside that little dip. So when you have a square root, you don't write it, but the index is 2. A cube root, the index is 3. So that's what index means. So here we've got z times the x root of y. Okay, so let's label all of these pieces. So x is our index because that's what's inside the little dip here. It doesn't really show, it might be better if you extend this a little bit further because x is supposed to be inside that little v. So x is our index. Z is being multiplied in front of the radical. So z is what we call the coefficient. Okay, now this is our radical symbol. And then under the radical is called the radicand. That's the y here. Okay, it's kind of like in division. You have a divisor on the outside, and then inside is the dividend. So it helps me to remember, if you have trouble with the terminology, if it's inside, it's the dividend, the radicand inside. So anyway, that's what the terminology is there. Let's look at some examples. Now over here in the margin, we've got some rules that we need to look at. When simplifying radicals, factor the insides of the radical. Then circle the pairs, triples, or quadruples, depending on the index, and pull them outside. Multiply outside factors on the outside and inside factors on the inside. Okay, so I'm going to show you what that means. And I'm thinking I'm going to go through and do the odd examples in the video, and maybe we can do the even examples together in class. So in example 1, I'm going to start by looking at the number inside the radical. Now first off, this is a cube root. My index is 3 because it's a 3 right here. I'm going to do a factor tree for the 54. I'm going to break it down as far as I can. So I know that 54 is divisible by 2, and it goes in 27 times. 2 is prime, so I'm not going to go any further, but 27 is divisible by 3, and that's times 9, so 3 times 9. And then 9 can be broken down as 3 times 3. Now at the ends of each branch, I'm left with prime numbers. There's nothing else that will go into 2 or 3. So this is as far as I can go. So I'm going to rewrite the original problem, and I'm going to say I've got the cube root. The 54 I can write as 2 times 3 times 3 times 3. And then y to the 10th, okay? So I can go ahead and expand that out. I know that means y times itself 10 times. So I'm going to write y times y times y, and I'm going to keep on going over here. Okay. Now that I've got all the factors listed out inside the radical, because it's a cube root, it's asking me for something that I can multiply by itself 3 times or cube to give me these values. So the cube root of 3 times 3 times 3 would be 3. So that's a number that I can take out. So because this is a cube root, because this index is a 3, I'm looking for triples. I'm looking for factors that appear exactly 3 times. So every time I find a set of 3, I'm going to circle it. Okay. Every triple that's been circled will come out of the radical. So I'm going to rewrite my cube root symbol. I'll leave some space out here. And anything that got circled 3 times can come out of the radical. So I can take out a 3 because of that group. I can take out y from this group. I can take out y from this group. I can take out y from this group. What's left inside? Well, the 2 didn't have anything to get grouped with, so 2 is still in there. And I can simplify this I've got 3 times y times y times y, so I'm going to say that's y cubed times the cube root of 2. So 3y cubed times cube root of 2. And that's my answer, and I'm going to put my answer in a box, so it's easy to locate. Let's look at let's do example 4 over here. Same thing, still a cube root, so I'm still going to be looking for sets of 3 inside my radical. I'll start with a factor tree for 27. So 27, I can break that down. I know that's 3 times 9. I know 9 is 3 times 3. And 3 is prime, so I can't go any further. So I have cube root of 3 times 3 times 3. I've got x to the 9th. And y to the 3rd. And I kind of box myself in over here. Y times y times y. And it's still all under my radical. Okay. I'm looking for groups of 3. Index being 3, I want groups of 3. So I can pull, there's a group of 3. Here's a group of 3. Here's a group of 3. Okay, and this time they all got grouped somewhere. So I can take out 3 for this group. I can take out x for this group. Take out x for this group. Take out x here. And take out y for that group. There's nothing left inside, so I can say it's the cube root of, if everything came out, then that means you just have a 1 sitting inside. Okay, and how can I simplify this? I've got 3 x to the 3rd power times y, and the cube root of 1 is equal to 1, since 1 times 1 times 1 equals 1. So I don't have to write times 1 here. I can just say 3x cubed y and put a box around my answer, and I'm done with example 4. Okay, let's move on to the next page. Let's do example, that was example 4. Let's do 7 and 8. No, let's do 6 and 8 here. Okay, so we've got some more directions to look at. When multiplying radicals, start by simplifying the radicals, if necessary. Then multiply outside by outside and inside by inside, and then simplify again. Okay, so in example 5, we're going to start by simplifying our radicals. So we got the square root of 40, which we're going to rewrite, and we got the square root of 20, which we're going to rewrite. So let's do a factor tree for 40. That's 2 times 20. 20 is 2 times 10. 10 is 2 times 5. These are all prime. So 40 is going to get replaced with 2 times 2 times 2 times 5. And that's all under my radical. With the 20, I can do the same thing. It's 2 times 10. 10 is 2 times 5. And 5 is prime, so I can't go any further. 2 times 2 times 5. Okay, now to simplify it, this is a square root this time. That means the index is 2, and that means that we need to find pairs. So if we find a pair of numbers being multiplied inside, we circle that pair. So here, since I've circled a pair of 2's, I can take 2 out of the radical. And then these 2 factors didn't have anything to get paired with. They stay inside, and I multiply 2 times 5, and I'm left with 10 inside the radical. And then over here in the second one, inside, I see I've got a pair of 2's. So I can take a 2 out. I'm going to put times here because I know I need to multiply. Square root 5. Okay, so they said to simplify the radicals first. So we've done that. Then multiply the outsides by outsides and insides by insides, and then simplify again. Okay, so on the outside, I've got 2 times 2 is 4. And on the inside, 10 times 5 is 50. And then simplify again. So now we need to simplify the square root of 50. All right, and I'm getting a little tight on space here. So I'm going to come down here. I'm going to do a factor tree for 50. And you may not have to do the factor tree to see what's going on with it, but it always works. So 50 is 2 times 25. 25 is 5 times 5. Now I have all primes. So that's 4 times the square root of 2 times 5 times 5. Okay. Inside I've got a pair of 5s. So that comes out. And when it comes out, it's going to get multiplied to the coefficient. So I'm going to put a little arrow right here to indicate my next step. 5 times 4 times the square root, and then the 2 is still inside. And then 5 times 4 gives me 20. So my answer is 20 times the square root of 2. Now it's very possible that this is not enough space for you to work here, so you could use a separate sheet of paper for your to write out your examples on, and that's perfectly fine. All right, and now we're going to look at, we did example 5. Let's take a look at example 7. Okay, so same directions. Simplify the inside first. So 8, if I factor it, it's 2 times 4. 4 is 2 times 2, so it's 2 times 2 times 2. So we have 2 square root 2 times 2 times 2 times 3. And then I can't simplify the 2 inside, so I'm going to just bring it down. Okay. All right, so the question is, what do my groups need to look like this time? These are square roots, so the index is 2. So because this is a 2 here, we're going to do a pair. Every time we see a number being multiplied by itself, we circle it. So here, the only thing I can circle are these, so I can take it out. This 2 I bring down, and I multiply, and then this pair comes out of the radical as another 2. And then I've got my square root symbol, and this 2 stays inside, like that, times. And then I can't do anything to simplify this, so I'm going to bring it down 3 times square root 2. So this gives me 4 times the square root of 2 times 3 square root 2. And now that I've simplified, the rules were to multiply the outside by the outside and the inside by the inside. So that would give me 12 times the square root of 4. The square root of 4 I know is 2. So it becomes 12 times 2. So my answer to example 7 is 24, and there's no square root left over. It's just a 24. Okay, let's look at adding radicals. Only add like terms, like radicands and indices. So simplify first and then add if possible. Okay, so that might not make perfect sense at first, so let's just simplify first. That's like we've just been doing. Do a factor tree for 72. 2 goes into 72 36 times. And then 36 is 2 times 18. 18 is 2 times 9. 9 is 3 times 3. Okay, so we have the square root. 2 times 2 times 2 times 3 times 3 plus 32. When I do it, I end up with 2 times 16, 2 times 8, 2 times 4, and 2 times 2. So that will be 2 times 2 times 2 times 2. Did I say that right? There's 5 of them. So 2 times 2 times 2 times 2 times 2. And I'm going to cramp there. All right. What kind of groups do I need? These are square roots. So I want pairs. So there's a pair of 2s I can circle. There's a pair of 3s I can circle. All right, so I could take a 2 out, I could take a 3 out, multiply them, and then this guy stays inside. Bring down the plus. Over here, again, it's a square root, so you need a pair. Take a 2 out, take a 2 out. 2 times 2 times the square root, and then this guy stays inside. So we could say that this is 2 times, that's going to be 6 square root 2 plus 4 square root 2. Okay, now it's a little different from what we had before because it's not being multiplied, it's being added. when you add these, you have to have like terms. In other words, if you think for a moment back when you were just learning basic algebra, okay? If you had 2x plus 2y, you couldn't combine these because they're not like terms, okay? So you can't do anything to combine that. You just leave it like it is. If you have 4x plus 6x, these are like terms, you can combine them. You would say that's 10x, okay? So in this problem, these are like terms. The reason they're like terms is because they have exactly the same radicals. So the index, they're both square roots. You don't have a square root and a cube root. They're both square roots. They both have the exact same numbers inside the square root. So these are like terms. Because they're like terms, you can combine them. 6 plus 4 is 10. So you'll say it's 10 square root 2 for your answer. Okay, let's skip over to example 4 and do this one together. All right, so in this one, we need to start with a factor tree for 81. That's going to be 3. You could do 9 times 9. That might seem obvious to you right off. And then 9 is 3 times 3. And 3 times 3 again. All right, so we're going to rewrite this as the cube root. It's 3 times 3 times 3 times 3 minus, and now I'm out of space, unfortunately, so I'm going to have to kind of squeeze it in. Let's do our factor tree for 24. So that's going to be 2 times 12. You can do 2 times 6. 6 is 2 times 3. Okay, so 2 times 2 times 2 times 3. And then this 2 still sits on the outside. So I'm going to have to kind of squeeze it over a little bit here. 2 from outside. Let me put my minus there. Okay. And then inside the cube root, 2 times 2 times 2 times 3. Okay. All right, now let's simplify this. So these are cube roots. That means I need to have a number 3 times before I can pull it out of the radical. So I can take this 3 out. 3 cube root 3 minus 2 times. Inside this radical, I see I've got 2 3 times. So I can take out a 2. And then I still have the 3 inside the cube root. So I've got 3 cube root 3 minus 4 cube root 3. And then these are like terms. I can combine them. If I do 3 minus 4, that gives me -1. So my answer is -1 cube root 3. Or the best way to say that is just simply negative cube root 3. And that's it there. Okay, so I'm going to stop here. There is a second part to this, but this is enough for the first video.